Greetings to another episode of the Dark Assassins podcast, a show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Have you ever wondered what random things would be if they were a programming language? No one, just me. Okay, well, I guess so much for this week's episode. I will catch you guys next time. So if you enjoyed, I'm just kidding. This week I kind of came up with this idea, which, to be honest with you, I was gonna make it like part of an Operation Core Dump type episode and just do like a couple things, like if X was a programming language, if Y was a programming language, and just kind of have a little bit of fun with it. But then I just kept coming up with things and then decided, okay, I guess this can just be a whole episode because why not? So sometimes we have some more serious episodes, but this is definitely going to fall into the category of a more lighthearted episode. But with all that said, all of this is totally my opinion. So if you disagree with any of them, by all means, leave a comment below if you're on YouTube, or you can shoot me an email, contact@darkassassinsinc.com, with what you think that thing should have been as far as a programming language is concerned. And if you have any, if I didn't mention something, because I'm only covering a small number of topics, relatively speaking, so if you have any things that you think would be cool to translate to a programming language, also be sure to let me know about those either in the comments or through an email. And if there's any good ones, I will definitely be sure to reference them in future episodes. But before we get into that, let's start off with this week's trivia question. So Apache and Nginx are two very common HTTP servers, but which one came first? So which HTTP server came first, Apache or Nginx? And that is your trivia question for the week. I guess bonus points if you can get the year too. But yeah, so with that, let's move right on into this week's cybersecurity tip. So this week's cybersecurity tip has more to do with protecting your personal information, but specifically in regards to your online identity, and that comes with obfuscating any public-facing IP addresses. So if you're into the self-hosting space, one thing that might come across your mind is potentially self-hosting something to be public-facing to the internet. Now, that's not necessarily a bad idea, but there are definitely some complications that come with publicly exposing services to the internet, especially if they are hosted at your house with a residential IP address. Because in case you weren't aware, anything that's publicly exposed to the internet is bound to get hounded by various bots online to try to break in to your system. Not to mention the fact that if somehow the IP address gets leaked, which if you don't take precautionary measures, it's pretty easy to leak it. Just by doing a DNS lookup, for instance, you can find the IP address. So if someone that doesn't like you finds your IP address, they can do what's called a DDoS attack, or a distributed denial of service attack, where essentially they just take down your entire internet because they flood you with tons and tons of traffic. Not a very fun situation to be in. The other thing that people can do to you is, if they know your real IP address and it happens to be your residential IP address, they can dox you, figure out where you live, at least in a general sense, what ISP you have, and all kinds of fun additional information about you that you probably don't want them knowing about you. Now, if you're hosting your public-facing service in the cloud, that's a little bit different because, of course, it's in the cloud, so it's not necessarily as big of a deal. But also, if you're just hosted on one IP address, the same things still apply, where DDoS attacks can happen fairly easily, and they can just kind of flood you with traffic. So there's a couple different ways that you can get around this. The first being to protect or obfuscate your IP address using something like a reverse proxy. So essentially you have a server set up that the domain name's pointing to, but then internally that proxy server will then redirect to your own IP address and thus not expose your personal IP address, but instead exposing the IP address of the proxy server. So that's one way you can get around not necessarily exposing your public IP address. You can also, if you're on a little bit of a bigger scale, you can use things like content delivery networks or CDNs. But another common one that people in the home lab space like to do if they want to expose something publicly is use something like Cloudflare or Cloudflare tunnels as a way to hide their IP address, but also to prevent against things like DDoS attacks. So there's a couple of different ways that you can protect your public IP from being easily discovered if it's a public-facing thing, but it's definitely something you should be looking into if you're thinking of hosting something, especially if you're doing it from your house. So that is your cybersecurity tip for the week. Moving right along into what nerdy stuff have I been up to this week? So I got back into some more video game programming. It honestly feels pretty good to be back. I kind of took a break from it for not any good reason. I didn't necessarily want to take a break from it, but kind of as I alluded to in last week's episode, I believe it was last week, part of that reason I think had to do with the fact that I kind of sort of wrapped up the thing that I was working on, that being kind of like the various Pokemon menus, so like the party menu and stuff. I kind of wrapped most of that up, so I was pretty much had to start not necessarily from scratch with something, but start something that I hadn't already laid some groundwork on, which kind of added roadblocks because I had to think of what I wanted to work on and then start it. But since I got the ball rolling, it's definitely been a lot easier to hop into it and write some code. So I've touched on the past couple weeks I've been working on the bag menu, kind of working with the inventory. Mainly at this point, just kind of working on implementing the GUI aspect of it. And as I was working on that, I wanted to be efficient with my sprite sheets and not duplicate unnecessary sprites, if you will. So one of them happens to be like directional arrows to like kind of point which ways that you can move like the cursor up and down and side to side and whatnot. And since they're the same, I figured there was no point in having 4 duplicate sprites when I could simply just have one and then rotate it accordingly. Because after all, I already have code in place to extract multiple sprites from the sprite sheet to my heart's content and do with them what I please. So I did that, and of course it didn't work. And then I had to figure out why it didn't work. And it turned out that it was just me being a bonehead, and I wasn't properly calculating offsets when I was performing rotation because I didn't adequately test the rotation aspect of things because I didn't really have much of a need to up until this point. So way to go me not thoroughly and rigorously testing my code. Don't be like me. Be a good programmer. But anyway, so that was a decent amount of the time trying to figure out and debug why that wasn't working. Really what happened with that was, so when I draw the sprite to the screen, I basically pass in the rotation that I want to have the Raylib library perform the rotation on the sprite itself. And when Raylib performs the rotation, it rotates it around an origin point. And the problem was when it was rotating it around the origin point, it was essentially either moving it to the left, up and to the left, or just up from where it was supposed to be, because I wasn't accounting for the fact that it was performing those rotations, so I didn't update the position of where the sprite should actually be on the screen appropriately. So because I'm essentially only rotating in 90-degree increments, I'm able to essentially hack it so I can just, shift the width or the height of the sprite either over and down or just over or just down in order to compensate for that. So it's not exactly the cleanest solution by any stretch of the imagination, and if I were to add other forms of rotation, like say 30 degrees or 45 degrees or something like that, my solution would basically fall apart. But because this is just a 2D sprite game, things are only ever going to be needed to be rotated in 90-degree increments. So my hacky solution is actually a fairly decent one. At least in my opinion. So that was kind of what I was working on, trying to get that squared away. But then I figured, I have a decent amount of this bag UI set up. I can navigate through all of the various pockets in the bag, but the problem is there's no items to go in the bag, right? So what's the point in having a bag menu if you don't have a bag? So that was another thing I started working on, creating a class to essentially hold all the various items in their various pocket containers. So I started working on and implementing the bag class, and I think I got most of it done. I think there's probably still some minor things that I'm going to need to do, but I got most of the big things done. I got the various pockets that need to be in there. I got the ability to add items, remove items, add multiple items at a time, remove multiple items at a time. So I think for the most part, that portion of the code is basically done, and I did write a decent amount of test cases within the bag test case as a whole to thoroughly test this, unlike my sprite extractor that I did not apparently thoroughly test, but I made sure I tested things like, giving every pocket some items, checking to make sure they were added properly, adding a single item at a time, adding multiple items at a time, trying to add more items than are able to be held by a single item, removing more items that would bring the value below zero, and things like that, trying to test some of those kinds of edge cases that you might potentially run into. Probably not, but who knows? The removing more than you have could potentially be an issue. Although you might be able to get around most of those edge cases with how you handle other parts of the user interface, but that's probably a little more likely than someone amassing a collection of like 65,000 and change of a single type of item. Not saying it's not possible, but probably not too likely. And I also, I guess in theory, could put caps on items too, but yeah, so I was trying to, test those kinds of edge cases, did some checks for memory leaks and was pretty good there. There was one minor issue I ran into when I started integrating it within the trainer class and then further within the game data. There was a really weird issue I was running into where, because I was allocating memory within the bag class, if I would reset the game data, for whatever reason, the bag class technically was still in scope, so the destructor didn't get called, but it also got recreated, so the memory got leaked. It was a really weird edge case because when I was testing everything with just the bag specifically standalone, never ran into that issue. It was only when I integrated it into the larger, broader scheme of where it was supposed to be that kind of ran into that edge case on occasion. So that was something I had to work around and get fixed. But overall, it's working pretty good. Now, of course, I still need to create more items, but the items in my mind are kind of like the individual Pokemon. Yes, they need to get done, but one, it's really low priority, if we're being honest. And two, it's not necessarily as big of a deal because at that point it's basically just data entry, right? It's just entering the requisite information to make the thing a thing. As far as like testing goes and implementing other features, you only need like a small handful of them just to test out the functionality and make sure your concept and everything works. But I will need to add more items. I think currently I have one at the moment, which I kind of needed at least one to test items in the Pokemon summary menu and in the party menu as a whole. I had to have at least an item in order to integrate that. But now that I actually have a bag and inventory thing, I'll probably create a few more, especially in the various different types of categories to make sure they get put where they're supposed to go. So that was the work I did so far this week. And I guess with that, we can move into the little game of if blank were a programming language. So I guess we can start off where I started off in thinking about this concept, and that was in regards to car transmissions. Now, if you aren't fully aware, I'm kind of sort of a car person. I do enjoy cars, so I figured it would be kind of interesting and fun to compare car transmissions to programming languages, and that is kind of how I got started down this rabbit hole in the first place. So the first one is the manual transmission. Now, personally, I'm giving this to C and C++. However, I have to give an honorable mention to assembly. And if you said assembly for this, I 100% get where you're coming from. And honestly, it was kind of a hard decision between the two but I ended up going with C and C++. But assembly is still a very good choice because if you look at assembly and a manual transmission, there are definitely a ton of similarities. One of them being it's both a manual process. I mean, if you've ever written any code in assembly, it is quite a manual process, manually putting values in registers, moving values in and out of memory locations. And if you thought, C was pretty verbose, assembly is way more verbose in regards to all that stuff. Because if you want to add two numbers together, first you got to move the values into the registers, then you have to add the registers, then you have to store that value back into memory, or you have to return that value. There's definitely a lot more manual steps involved. But to me, there was just enough abstraction with a manual transmission, and to me, assembly was just a little bit too low level for a manual transmission. Now, don't get me wrong, a manual transmission is definitely a manual process, with the fact that you have to, manually push in a clutch and move the gear shift around. So it definitely is still a very, very manual process, but which is kind of why you might think of going with assembly because, a manual seems about as low as you can get. Because, like I said, you're pushing in the clutch to disengage the transmission from the drive shaft, you select your gear, then you release the clutch to re-engage the transmission and the drive shaft, which sounds kind of a lot like, loading values into registers, performing some kind of operation and saving that back out to memory. But personally, for me, I would argue it's a little more akin to C and C++, though, since you have a clutch pedal and a gear selector as your intermediary between you, the transmission, and the drive shaft. Just like in C and C++, you have the compiler in between you and the machine code. So when you're writing C and C++ code, you're not, specifically putting the memory into the registers. You're writing the code that does that, but the compiler is kind of the one that does that for you. Just like in a manual transmission, you're pushing in the clutch and moving the gear shifter around, but the act of pushing in the clutch and moving the gear shifter, it's not like you are physically inside the car disconnecting the transmission from the drive shaft and then like manually with your hands selecting the gear and putting them back together. To me, that would be hands down assembly. But quite honestly, I'm being pretty nitpicky here, which is why I have assembly as an honorable mention. And if you put assembly as your programming language for a manual transmission, I 100% will give that to you. I won't, try to argue it too much. It's not necessarily a hill I'm going to die on, trying to argue that it's not assembly, which is kind of why I gave it an honorable mention. But why specifically did I go with C and C++? Well, like a manual transmission, C and C++ give you total control of everything. You get control of your memory management, resource allocation, and you get physical access to the hardware itself to control components directly. Just like in a manual, you get access to everything. You can manually select which gear you want to be in at any given time. And just like C and C++, manuals allow you ample opportunity to shoot yourself in the foot. Because in C and C++, I'm going to sound like a broken record here, but of course you have your classic overflows, your buffer overflows, classic one, overwriting the bounds of arrays, using memory after you free it, arbitrarily trying to access memory that doesn't exist, all those fun things that come with using C and C++, all those fun foot guns that we love to shoot ourselves with. And then similarly in a manual, there are other things that you can do to essentially shoot yourself in the foot. Things like stalling the car, money shifting, and forgetting to put the parking brake on. Because now, I guess if you're unfamiliar with the term money shifting, essentially what that means is you're trying to shift into a higher gear, but accidentally shift into a lower gear when the car is under load. So imagine, for instance, you were doing a little bit of spirited driving, if you will, and you were currently in, say, fourth gear. You were really high in the RPM ranges, maybe getting close to red line, who knows, and you go to shift into fifth gear, but instead of, say, going up and to the right, you just go straight up and shift into third. Not a very good time. That is what we call a money shift. And then, of course, forgetting the parking brake, because manual transmissions don't have a park. So if you want to park the car, that's what the parking brake's for. But if you haven't driven one in a while, you might forget to do that, and then the car basically can just roll. So not what you want to do. So kind of another foot gun there. So that is kind of in a nutshell why I went with C and C++ for that. Now, getting into another kind of transmission, the dual clutch transmission. So the dual clutch transmission kind of sort of operates like an automatic in times, but you can also kind of switch it over into a manual mode where you can use paddle shifters to select which gear you want to be in. So for this, I am giving Rust the programming language for a dual clutch transmission, because similar to Rust, you have those safety checks in place that prevent some of those common, memory-related bugs like C and C++ have, right? You have the borrow checker, you have bounds checking, kind of all built in. But also in Rust, if you want to have some fun, you can use the unsafe keyword and deal directly with memory. Similarly, with the dual clutch transmission, there's more than one clutch involved, so it makes kind of the smoothing out of the gear shift, so you don't necessarily have that jerkiness when you're shifting between the gears like you do in a manual transmission. So kind of like with Rust, it's kind of a smoother experience, if you will, when kind of writing like systems level code. You don't necessarily have to worry as much about all that memory management stuff. Kind of smooths out the development process, if you will, and then all those extra built-in bounds checks kind of, negates at least a little bit of all the verboseness of error checking and things you have to do in C and C++ to make sure you're accounting for those various bounds checks. And also, with the dual clutch transmissions, it also prevents you from doing things like money shifting, because you can't accidentally shift down because you either press the paddle to go up or press the paddle to go down. So if you press the paddle to go down and you didn't intend for that, I'm not exactly sure what you were thinking. But, kind of as we mentioned, Rust, has some of these built-in checks to kind of ensure and to protect you from falling victim from some of those common memory-related vulnerabilities. And then, of course, both the dual clutch transmission and Rust are both very performance-oriented, so that is why I ended up going with Rust for the dual clutch transmission. Now, getting into the automatic transmission, I mean, this is about as basic as it gets, so I decided to go with Python for this one. Because anyone who can drive an automatic transmission, and anyone who can write code can write in Python. Now, of course, not everyone that can write code can write in Python. When I first started learning how to program, I did not know how to write in Python because Python was not the first language I learned. But as a general rule of thumb, if someone's been programming for a while, there is I would say a pretty strong likelihood that they either know how to program in Python or they can at least fumble their way around it, because if you've ever written pseudocode, that's basically almost the same as writing Python. The syntax is pretty similar. So it's a pretty easy language to pick up, and almost anyone that can write code can write in Python, just like basically anyone that can drive an automatic, because everything in an automatic is basically abstracted away from you. Do you want the car to go or do you want the car to stop? You have a pedal to go and a pedal to stop. It's pretty simple. So just like in Python, everything is basically abstracted away as well. Now, the keen-eyed among you might be trying to point out some cracks in this comparison here with Python, because I can hear some of you saying, and rightly so, that some automatics have paddle shifters or some kind of manual mode, which kind of blows the Python comparison out of the water. Now, I said that some automatics have some sort of manual mode, and how is that different than a dual clutch transmission that kind of has an automatic mode, but you also have the manual mode with the paddle shifters? Well, the difference is the dual clutch has multiple clutches. It has more than one, hence the name, whereas an automatic uses a torque converter in order to transition between the gears, so a little bit different. So the dual clutch, when you shift, essentially what's going on to give you that smoothness is one clutch always essentially stays in gear until kind of the other one can activate, I guess, if you will. That's not the right word, but engage. I guess engage is the word I was looking for. To kind of smooth out the jerkiness. But an automatic doesn't use a clutch; it uses a torque converter in order to shift around. But the other thing about automatics too is even if you swap into the quote-unquote manual mode with an automatic and you don't shift soon enough, the car will just shift for you. So in reality, while automatics might have a manual mode in them, the shifting is more like a suggestion to the car, or it's more like a guideline rather than a definitive go into this next gear. Because it's just one of the various mechanisms that automatics use to try to protect themselves from bad drivers, I guess. So getting back to Python, though, Python does give you a decent number, where I guess I'm trying to push back against the cracks here. Python does give you a decent amount of abstractions to interface directly with the operating system and the hardware if you need it. For instance, you can open up network sockets, you can work with files, having that file I/O, and probably the biggest point of interfacing directly with the hardware is all the various libraries that exist out there that allow you to integrate with GPUs. Specifically, I'm thinking of like TensorFlow and PyTorch. So sure, it's not like, CUDA programming where you're writing code specifically for the GPU, but at the same time, it's kind of like in an automatic where you're not physically, shifting gears either, but you're telling the car like, hey, I would like you to change gears, please. Just like in Python, if you're using a library like PyTorch or TensorFlow, you're kind of telling the Python interpreter, hey, I would like to run this code on the GPU. So yeah, sure, it's not, exactly interfacing directly with the hardware, but you're kind of giving the suggestions of, hey, can I do this, please? And then, the interpreter and the operating system, if you're using like a system type call, will, hopefully oblige your your request. So that was my choice for automatic. Now, the last one I'm going to touch on here is the CVT. And the CVT is it's basically kind of another flavor of automatic in a sense, but essentially how it works is, unlike an automatic that has the torque converter to shift gears, the CVT doesn't have gears. It just uses belts and pulleys, and it uses a computer to essentially send information to the transmission to adjust the rotation of the belts and pulleys in lieu of gears, essentially trying to make it for an even smoother ride than an automatic. But my choice for the CVT transmission is JavaScript, because in the same vein, JavaScript is essentially full automatic as well. There's no memory or resource control involved. And similarly to the CVT, CVTs are basically the economy car's transmission of choice, since they tend to get the best gas mileage in terms of engine transmissions. And especially today with how much of the world is built on the web these days, so too are projects built in JavaScript, much to my dismay. But since JavaScript natively runs in the browser, it kind of makes it the kind of ideal choice for web-based applications, because if you're creating an application to run in a web browser and the web browser can already natively run JavaScript, what's the point in trying to reinvent the wheel and do some other weird conversion thing from a different language when you can just use JavaScript that'll natively run? And the other thing, too, kind of why I picked JavaScript is because both JavaScript and CVTs are, they have the community is very split on them, right? Like, if you ask car enthusiasts what their opinions on a CVT is, they're probably not going to necessarily think too highly of it. And if you ask, just a normal person what they think of a CVT, they probably have no idea what you're talking about. But if you ask them, what do you think of, the transmission in like your, I don't know, whatever CVT economy car you have, they'll probably be like, oh yeah, I mean, it gets good gas mileage and stuff, and they probably won't really have anything necessarily bad to say about it. Just kind of like in the programming developer community, it can be kind of divisive. Some people like JavaScript and some people really don't. But also the similarities don't end there, because neither CVTs or JavaScript are particularly known for their performance. As a matter of fact, there have been numerous times I've encountered where web pages just don't load very fast. Go ahead and disable the JavaScript and they are very snappy. Don't think that's necessarily a coincidence. But also, if you're anyone that's looking for a performance-oriented car is not going to pick a CVT, just like anyone looking for a performance-oriented language is not going to pick JavaScript. So those were car transmissions and how they would equate to programming languages. I'd be interested to hear what your thoughts are on those. Now, moving into the next section, I like to talk about Apple stuff from time to time on the podcast, so I figured, what if Apple computers were programming languages? So I guess we can start off with the basic one, which is, of course, the MacBook Air. And I think rightfully so, I went with Python on this one. Python, of course, pretty lightweight, easy to learn, and versatile. The use cases for Python is pretty wide-ranging. You can use it for all sorts of tasks. Now, of course, it's not the most powerful or the quickest language out there in the world, but it excels at simplicity and readability. Just like the MacBook Air, it's a very solid machine, especially nowadays with Apple Silicon in it. Before, in the Intel days, it was kind of anemic at times, but even still, it was kind of like the everyday bland, basic. If you need a cheap Mac and you don't necessarily care about performance, but you just want something that'll get the job done, MacBook Air was basically the recommendation. And especially nowadays with Apple Silicon, it's basically the default choice unless you need more power. And just kind of like with programming projects, like Python is, in my opinion, kind of the default choice unless you need something more like performance oriented, because the use cases of Python are so vast, and it's so quick to develop something in Python and so quick to spin something up. It's very attractive for if you just want something quick, down and dirty, which it's a great language for that. Moving into the next Apple computer, the iMac, I'm going with Java on this one, since the iMac is kind of like Java in the sense that they're both do-it-all machines, right? Like Java was kind of built and has the stigma of you write once and it runs everywhere, or in the cybersecurity community, you write once and exploit everywhere, whichever flavor you want to go with. But you can write, a wide range of applications, from command line applications to GUI applications, and you can even make it work with distributed file systems using like Apache Hadoop. You can work with distributed file systems that way. And one of the nice things about Java is it has a built-in graphics library in it. I mean, now granted, it's not the most advanced graphics library, but it's pretty simple if you just want to make something really basic with like some drop-down menus and windows and that kind of a thing. It's very basic, but for someone like me that's not very graphic design, don't have much experience with it and not good at it, it's very easy to just add a drop down here, add a radio button there, add a text field there. Pretty easy to use, especially if you have a tool like Eclipse or something that has a built-in like GUI editor. It makes working with Java GUIs pretty simple. But like I said, you can write command line applications, GUI applications, server applications. It's kind of like a one size fits all kind of a solution. It's pretty performant for what it is, because unlike a Python that's fully interpreted, while Java doesn't compile down to machine code, it compiles down to the Java bytecode, which is then interpreted by the Java virtual machine, which, it's not going to be as fast as, a natively compiled, program like a C or a C++ or even Rust, but it's still going to be significantly faster than an interpreted language like Python is. Or any other scripting language. So similarly, the iMac is kind of this all-in-one, do-anything kind of system too, right? You can basically do whatever you want with it, and historically, it kind of had that perfect balance of performance and value, especially when you considered the fact that when you bought an iMac, and even still when you buy an iMac, you not only get the computer, but you also get the mouse, the keyboard, and a fantastic screen to boot. All within a fairly, affordable, at least for Apple standards anyway, package. And there've been comparisons over the years, especially like if you specifically, picked out the components that Apple used in the iMac was a fantastic deal. Now, you could make the argument, were those the best components for the job? You could make the argument that they're not, but assuming you went out third party and built your own PC with the exact same components that made up the iMac, and then threw in, a super high resolution display and, mouse, keyboard, speakers, webcam, all that stuff, once you factored all that in, the iMac was actually cheaper. But anyway, that aside, the performance was also pretty solid too. It was kind of, especially in the Intel days, it was like this solid medium. It wasn't necessarily quite Mac Pro, although when they came out with the 2013 Mac Pro and then never updated it, some of the iMacs kind of outperformed that Mac Pro, but that's kind of besides the point. But it was, better than, a laptop, but not quite, like the pro level Mac Pro type of computer. But it was a really solid, like mid-ground, just kind of like Java is. It's not the most performant language, but it's also, not the slowest either. And it's just a pretty solid all-around language. Next, moving into probably one of my favorite Macs, the Mac Mini. Now, the Mac Mini, I'm giving it the C programming language, not because of any kind of performance reasons, because historically the Mac Mini was never necessarily a powerhouse. I mean, of course, with Apple Silicon, pretty much any Mac with Apple Silicon is kind of a powerhouse. But historically, the Mac Mini wasn't really anything to write home about per se. I mean, it was essentially running MacBook Pro chips just in a desktop enclosure. That's essentially what it was. Now, granted, the 2012 Mac Mini was probably the best one they made, at least until like 2018. But even still, like in 2018, the kind of the funny thing about that was the base model Mac Mini in 2018 was essentially on par, at least performance-wise, with a Mac Mini from 2012, like the higher-end spec with the quad-core i7. But anyway, we're kind of getting off track here. The reason why I picked the Mac Mini for C, or why I picked C for the Mac Mini, is if you want something done in C, you basically have to do it yourself. Or you have to, find a library that will do it for you. Because the footprint and standard library of C is very minimal. So you basically have to bring a lot of your own code, if you will. If you want to do something simple, like in Python, that's a one-liner. In C, you might have to write a function that's like tens of lines long just to do essentially what's a one-liner in Python. So it's a lot more verbose, and you have to add a bunch of extra stuff to it in order to make things work. But it's kind of like the Mac Mini, right? Like it's very customizable in that sense. Like in C, you have a lot of customizability and the functions that you write to perform the tasks that you wanted to perform. Just like on a Mac Mini, everything is bring your own. The classic BYODKM, the bring your own display, keyboard and mouse. So just kind of like C, where you kind of have to bring all your own code to make the project work. With the Mac Mini, you pretty much have to bring all your own stuff to make it work. So that's why I picked C for the Mac Mini. Moving into the Mac Pro, I went with Swift for this one. And the main reason I went with Swift was, well, one, Swift is a pretty performant language. It's, a compiled language. It's pretty darn fast. It competes, with other compiled languages like Rust, C, and C++. But the main reason I went with Swift is because the Mac Pro is essentially Apple's flagship computer, let alone desktop, right? It's their flagship computer. It's the most expensive, and historically it's always been the most performant. And just like with Swift, Swift is their flagship programming language at this point. So I think it kind of made sense to kind of marry the two, their flagship programming language, which happens to be Swift, and their flagship desktop, which happens to be the Mac Pro. And both of them historically have been both very fast, very sleek looking, and very clean things respectively. Like the design of the Mac Pro historically has been pretty sleek and clean, and if you've ever seen Swift code, it's definitely pretty clean as well. Moving into one of my other favorite Macs, the Xserve. Now, this one, I went with Objective-C for this one. Not because I like Objective-C. To be honest, I'm not necessarily the biggest fan of Objective-C. But the reason why I went with Objective-C for the Xserve is because they were both powerhouses at one point in time, but they have kind of since gone the way of the dinosaurs. Now, granted, Objective-C is not dead like the Xserve is, although, as I like to say, long live the Xserve. The Xserve is definitely still alive and well, in my opinion. But from Apple's perspective, the Xserve has long since been dead. But the reason why I went with Objective-C is because, back in the day, it was kind of Apple's, flagship programming language before they kind of started developing Swift. So yeah, Objective-C still exists because Swift still relies on it for some things, but it's definitely by no means nearly as mainstream as C or as Swift is. Just like the Xserve used to be kind of, a big powerhouse. Actually, I don't know how much of a powerhouse it was. Performance-wise, I mean, it was basically a Mac Pro, but of course a 1U rack mount system. So, I mean, it had some, some performance, back in the day, but since then it's kind of, fallen off. Moving into the last one I wanted to touch on for Apple desktops or Apple computers in general is the MacBook Pro. Now, I am going with C++ for this one. So now, especially with MacBook Pros now with Apple Silicon, MacBook Pros pack a ton of power into a very portable package. Now, granted, they're not going to be as thin and light and sleek as something like a MacBook Air, but they also pack a lot more punch than a MacBook Air does. Just like C++, you can really pack a punch with C++. It's a very performant programming language. But at the same time, if you've looked at some of the modern features of C++ and how to use them, they don't exactly make for the cleanest looking of code, no matter how you format it. Just like with the MacBook Pro, yeah, it packs a punch, but it's not going to be as sleek, clean, and thin looking as something like a MacBook Air is. So that's why I went with C++ for the MacBook Pro. And the last kind of subsection I wanted to talk about for this episode is sports. Now, if you have any, like I said kind of a couple times throughout the episode, if you have any ideas for future things that you want me to compare to as programming languages, definitely leave those down below, either in the comments on YouTube, or you can shoot me an email at contact@darkassassinsinc.com, and maybe we can do another one of these episodes, assuming you guys are enjoying it as much as I am. So the first sport I wanted to talk about is football. Of course, the real football, that being American football. So I went with C and C++ for this one. And the reason I went with that is because C and C++, while not necessarily as pronounced as some other programming languages out there, they are still titans in the software development world, even decades after their creation. So similarly with football, it basically dominates the ratings and trounces basically every other sport, at least here in the U.S., when it comes to, average viewership and like on Sundays, if you're a sport that's not the NFL and you're trying to broadcast something on Sunday, good luck getting viewership, especially in the fall during football season. Even college football, rakes in a lot of viewers as well. But specifically in how it relates to C and C++, being a good football player requires strength, speed, and a high level awareness of what's going on the field. Just like with C and C++, C and C++ in terms of performance are kind of like football in the sense that they're very performant, and you have to be very performant to be good at football. Both take lots of practice to be good at. Things like memory management, especially in C and C++, can be difficult to master, and especially with C++, all those built-in functions that they keep adding every C++ release, all those functions at your disposal. It takes a long time to familiar yourself with all those and get good at using them effectively. And just like in football, where you need to have good situational awareness of knowing what's going on, in C and C++, you need to have pretty good situational awareness to make sure you're adequately controlling your memory, not letting things go out of bounds or accessing memory after it's already been freed, all those fun memory potential vulnerabilities that we've talked about in the past. So that is why I went with C and C++ for football. The next sport I wanted to talk about was baseball, and this one I gave Java for the baseball programming language because both of them are basically classics. I mean, Java is definitely not the fastest or the flashiest of programming languages, but it's still one of the most dominant when it comes to industry use, which is kind of similar to baseball, right? It's not the flashiest. It's not, a super flashy sport like basketball is. It's not as hard-hitting as football, but it's called America's pastime for a reason. Both are very robust and mature in their own right. And definitely won't be going anywhere anytime soon. So that's why I went with Java for baseball. Now moving into the next sport, I'm going to go with basketball here. And for basketball, I went with Swift. Now, granted, this is mostly for the name more than anything, because if you've ever watched a basketball game, kind of the effortless dribble moves, dunks, and fadeaway shots that you see, I mean, the effortlessness and kind of swiftness of all those movements just, kind of scream Swift, if you will, which is kind of why I went with it. But as far as going beyond just the name of the programming language, um, kind of as we touched on before, Swift is also a pretty performance-oriented language. It's a compiled language, of course, and it's very fast in terms of its performance. And of course, the name sounds pretty good too. Now, I guess also, as I kind of, walked through that, Go would also probably be a good one, for the naming reason, because, basketball is a pretty fast-paced sport for the most part. Now, of course, fourth quarter comes around and they start the foul game. It kind of grinds to a halt a little bit. And then of course, anytime there's foul shots or timeouts or whatever, the game kind of stops. But Go wouldn't be a terrible one for that, but I ended up going with Swift. Now, speaking of Go is what I selected for hockey, because if you've ever watched a hockey game, there's basically no stopping at all. There's timeouts, but there's no mandatory breaks where, lineups switch in and out, right? Like, if you've ever watched a hockey game, there's a constant stream of, hockey players, skating around on the ice, and then one will hop into the box, and then another guy will hop out, and the play just goes and goes and goes. So I went with Go for that, partially for the go nature of it, but also it's not just surface level, because Go has quite honestly become a fairly widely used language for back-end servers. And if you've ever written anything that's like a back-end server, whether it's for some kind of like REST API or other sort of web interface or just a back-end server in general, if it's meant to be in production, those kinds of servers are going to have to be go, and they're going to get hit pretty hard, pretty consistently. Just like in hockey, the players get hit pretty hard and pretty consistently, whether that's getting, checked up against a wall or they decide to get into a little bit of a fist fight. It's pretty much go, and pretty brutal. Gotta take the punches, and Go, kind of becoming more widely used, in the back end server development. It is pretty go, just like hockey. And the next sport I wanted to talk about is golf. So a fantastic sport, very exciting, very entertaining. A little bit of sarcasm there. But golf isn't, of course, the fastest pace sport. If you've ever watched it on TV, that's probably pretty evident. But it's also not the flashiest either. But it's a sport that you don't really gain an appreciation for unless you've tried to play it and realized how hard it is. Because if you've never played golf before, and you think and you maybe watched it on TV and you think it's easy, I encourage you to try to play golf, because it is definitely a lot harder than it looks. But if you can master it, you can basically make it look as effortless as the guys on TV and the pros. So for golf, I decided to go with the Bash programming language, because Bash, of course, it's a scripting language, so it's not the fastest language. Just like golf, it's not the fastest game in the world. It's pretty slow. Whether you're, walking the course or you're riding a golf cart, even still, I mean, it takes hours just to play 18 holes of golf, and that's assuming you don't have a slow group in front of you or you have slow people in your group. So again, not the fastest, just like Bash isn't the fastest programming language. And its syntax isn't exactly the cleanest, and it's not necessarily the most straightforward. And it can be kind of daunting for new programmers, especially if they're trying to do something more complex than just stringing together a bunch of, Linux commands to run sequentially. But with that said, if you can master Bash, it makes automating things in a Unix-based system an absolute breeze and can make your life so much easier and streamline a ton of things and basically make them look effortless, because all you have to do is you run the script with a single command, and then your script automates whatever you told the script to do. Because just like any other programming language, you can, make use of conditionals. Those, of course, being like the if-else kind of statements. You can take in, arguments to, configure things. And there's a ton of stuff you can do with Bash, but it also, kind of takes some skill and some getting used to, because it's not, a super easy to pick up language, say like Python is. But assuming that you can master it, it will make your control of Unix-based systems very seamless and can kind of make you look like a wizard. So that's why I went with Bash for golf. The next one is kind of a large lump sum. I kind of lumped all auto racing sports into one thing. So whether that's Formula One, IMSA, the WEC, NASCAR, IndyCar, anything dealing with auto racing, I kind of lumped into one. And I, of course, had to give that to assembly. Now, I hope it's kind of self-explanatory why I picked assembly, but in case it's not, auto racing is more than just drivers driving fast around a track, or if it's NASCAR, driving in circles and making left turns. There's a lot more to it than that. There's teams of engineers that have to build and test every component of the car. Like if you've ever looked into the engineering feats that go into something like Formula One, it's quite mind-blowing, some of the engineering, things that go into this. They're trying to pull every ounce of performance just to get a leg up on the next guy, because the thing with auto racing is there's so many rules in place in order to ensure that the cars are competitive, right? Because it wouldn't necessarily be all that fun to have, say like a Formula One car going around like a road course against a NASCAR. The NASCAR is going to get smoked. It's going to stand no chance, and it's going to be a very boring race to watch because you already know the outcome. So that's why, they have all these rules in place in order to make the cars as close to they are as possible, as identical as possible, while also being different in order to make sure that they're competitive. So when you have that many rules, you basically have to dig into, the fine details and kind of look where you can either skirt around the rules, so then they'll end up making more rules, or how you can basically engineer, take advantage of all the minor things, whether that's aerodynamics or engine displacement or drivetrain or whatever, any small minor thing you can think of in order to give yourself that little bit of an edge over the other guy. So there's a lot of engineering involved, and just like assembly, you're basically hands-on with the machine code, moving things, as we talked about earlier with the manual transmission portion, moving values into registers, moving them out of registers, moving things in and out of memory, all that manual process, and all the low-level details and having that direct control. Assembly also is very performance and optimization focused, especially back in the day before processors and compilers were as good as they are now. But this relentless pursuit for speed and efficiency is basically what defines auto racing, and it's kind of what defines assembly too. Because, back in the day, as I kind of mentioned just a second ago, when processors weren't as powerful as they are today, if you wanted the most performance out of your application, you were writing it in assembly. It wasn't like, okay, you want a performance application, okay, write it in some compiled language like C++ or Rust. No, you wrote it in assembly because you needed to extract every ounce of performance you could out of that machine in order to make your program run as optimally as possible. Because also back in the day, compilers weren't nearly as good as they are today. Now, they weren't horrible, but someone that was well versed in assembly could outdo a program compiled in C, for instance. If they were really good at assembly, they could write a more efficient program in assembly than C. So that's why one of the other reasons why I picked assembly for auto racing. And the last sport I wanted, well, I guess there's two more. The second to last sport I wanted to touch on is soccer, or as anyone not in the U.S. would try to claim, football. But soccer is while football is kind of the titan in the U.S., soccer is basically the titan everywhere else. And because, soccer is such a widely viewed and enjoyed sport everywhere, Python is kind of the same thing in the programming world, which is why I went with Python for it. Because basically, if you want to whip up something quick, Python is your go-to. You don't turn to C if you want to write a quick down and dirty script. You use Python. And soccer is a very fluid and constantly moving game, kind of sort of like hockey, but also you don't constantly have people running into each other and checking each other. Now, of course, you have the hilarious flops in soccer, but it for the most part, it's fairly moving. People are always moving around. The ball is always moving, and similarly with Python, it's very quick and easy to change things on the fly, make edits, whips up programs in general, and tweak things without having to recompile the entire code base, which is another one of the reasons why Python is such an appealing programming language, amongst, the fact that it's very easy to write in. The last one I want to touch on, this one's just going to be really quick, is pickleball. Now, I'm going to be honest with you guys, I don't really know anything about pickleball, but what I do know about pickleball is it is kind of an up-and-comer, and it's kind of this new hot thing, if you will. So I think the obvious choice is Rust, because Rust is kind of the language that's been coming along the past few years, and everyone's like, oh, we need to rewrite everything in Rust, because it's a memory-safe language, and it's a compiled systems programming language, and it's going to be the C killer, and it's going to revolutionize everything, and everything has to be in Rust. And I don't really know much about pickleball, but I know pickleball has kind of been gaining a lot of steam, and everyone seems to be talking about it. So that's why I went with pickleball. No other reason for it. It might be a horrible comparison. So if you have a better comparison for pickleball as a programming language, I would love to hear it down below in the comments, or you can shoot me an email. But yeah, so those were the random everyday objects and concepts that I thought of. What would they be if they were a programming language? So as I've kind of mentioned a couple times, I'd be interested to hear what your thoughts are on these. If you think they would be a different programming language, what you would have picked for these. And like I said, if you have other random things or ideas that you would think would be interesting to know if they were programming languages, I'd be interested to hear about those either in the comments below, or you can shoot me an email at contact@darkassassins.com. And if we get enough submissions, I will definitely make a follow-up to this episode and have even more if blank were a programming language. And we can continue this kind of as a fun little thing here. Now, before we go, let's get back to our trivia question for the week. So Apache and Nginx are two common HTTP servers, but which one came first? So did Apache's HTTP server or Nginx's HTTP server come first? If you said Apache, congratulations, you got this week's trivia question correct. And as I alluded to in the beginning, I would give bonus points if you got the years. Apache came out in 1995 and Nginx came out in 2004. So if you either got the trivia question and or the bonus correct, congratulations for this week. And if you enjoyed this episode, definitely be sure to give it a rating and review and subscribe if you haven't done so already. And be sure to share this episode around. I think it was kind of more of a fun, lighthearted one, not necessarily super into the technical weeds that we sometimes get into. So maybe it's a little more palatable for some of your, non-super tech enthused or aware friends or family members. But if you have any questions about this episode, or you have any topics, ideas, or comments for future episodes, you can either leave a comment down below on YouTube, or you can shoot me an email at contact@darkassassinsinc.com. And that is going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.